Someone have a question on the homework? All right. Can somebody pick one off 1B that we didn't get to yesterday? Is it this one? Okay. So what could we do first? We could change the tangent to like sine over cosine or sine squared over cosine squared, but is there something, I'm not sure, because like I said, I don't always have these memorized very well, but is there something we can trade the whole parenthesis for here? Okay, hang on, having cursor issues as usual. Okay. So you're telling me 1 plus tangent squared is a secant squared? And on the quiz, you need to make sure that I can follow what you did, okay? Now, what do you want to do with a secant squared? Okay, so this one is staying the same, and this is 1 over cosine squared. And then since this was over 1, what could we do? Yeah, cosine squared, everybody's clear that that really means cosine times cosine, right? You don't have to write it out like that. I just want you to understand that if you cancel one of them, there's still a cosine down there. So we end up with 1 over cosine, which is okay. We can. Oh, I didn't assign one that had this complement of the angle. If you had it on your sheet, cosine of, this is basically 90 minus x, would become sine. Okay. It's not one you have. On your sheet, but this would just be sine of x. And then you'd have sine divided by cosecant is 1 over sine plus a cosine squared. And then this fraction is sine, but you're dividing by 1 over sine, which means you're multiplying by the reciprocal. So what's that all become? Eventually, yes, this becomes sine squared. And then there was a plus cosine squared. So it simplifies down to 1. But that first step, I'm not going to ask you one like that. Okay. All right. I have another little warm-up I wanted to do today. I want you to remind me what law of cosine and sine look like. You don't have these, but you're welcome to write them down because they're just like ones on the quiz. Law of sines, what's that look like? So sine of some angle over the corresponding side. And you could be C over C. Everybody good? The thing to remember with law of sines is if you end up doing inverse sine of something and getting an angle, do you remember what has to happen? When you do second sine and you find an angle, you have to always examine the possibility that 180 minus that angle A is also possible. And the reason for that is, if we're thinking about the sine, an angle can be anywhere from, if this is the unit circle, an angle can be anywhere from 0 to 180 in a triangle, in theory, right? And the sine values up here are all positive. So if you get a sine value back here of 1/2 or back here of 1/2, you don't know if the angle was 30 or 150, okay? Could be either one in the triangle. Sometimes you can eliminate it because if you already have a 70, can you have a 150 as well? No, because it's got to stay under 200. But whenever you do inverse sine, okay, that's the trick with law of sines. All right, what does law of cosines look like? If somebody pick a letter, go ahead. Okay, gotta have it memorized. So it's the side across from the angle squared equals the other two sides squared and added together minus 2 times the two adjacent sides here times the cosine of b. Now, the thing students do is they want to type all this in at once. Can you do that? Does anybody know why? This is all multiplied together back here, right? So we have to be careful. What makes this tricky is if you're solving for the angle, you're going to take the b, subtract these two over to the other side. Whoops, that's supposed to be a c. And then that would leave you all of this that's still multiplied by cosine. So to get rid of it, you're going to divide. And that would give you the cosine. And then you'd have to carefully put that in and do inverse cosine. Okay. So let's practice. This question 21, I just want to find side B. So I draw a triangle ABC. It says angle A is 61 degrees. Side A across from it is 14. Side B is 15. I want to find angle B. Okay? How do I set that up? How do I know what to use? I actually have angle side, which isn't a postulate, but I have one across from each other here. Okay, so I can set up the sine of 61 degrees is across from 14. In the same way, the sine of B is across from 15. What mode should I be in? Degrees. Okay, and how am I going to type that in? Cross multiply, right? So sine of 61 times 15. When I type in sine of 61, I need to make sure that I close my parenthesis. Then times 15. And that's going to be 14 times the sine of b, so I'm going to need to divide by 14. And that's going to give me a funky decimal. Great. I picked one that's, oh, I might not be in the right mode. Let's check. Nope. What did I do, Kayvon? Yep. And then hit enter so that you don't have to close the parenthesis and then divide by the 14. So it's the same number of keystrokes, okay? If I had typed it in here correctly in the right mode, I would have got the same thing that Kayvon did in 2 steps, okay? Now, that's the sine of B. So I'm going to have to do second sine. As soon as you do second sine on the calculator, you should be thinking 2 possible solutions, okay? So second sine of this answer gives me 69.6. And then if I do 180 minus that, I get 110.1. Now, can I eliminate either one of those? If I look at the figure, angle B has to be bigger than 61, right? Because it's across from a longer side. Both of those are bigger. Can I have a 61 and 110 in a triangle? Yeah, that makes 171.1 or something. It's okay, there's room for a third angle, so I cannot eliminate either of these. One more explanation of why this works. Do you remember your geometry teacher writing that on the board and telling you there's no geometry theorem that says that? No donkey theorem? Okay, that's what we were given. We were given an angle over here, a side here, and a side here. The reason there is no theorem is because it doesn't determine one unique triangle. It can possibly have two different triangles. Now I could make this real complicated, make you solve the whole triangle, but I'm not going to do that. Okay, you're just going to have to find a missing angle. All right. This is number 32 from the bookwork. It says find angle G. If I draw the triangle real quick, F, G, H, side F is 39 across from the angle here. Side G is 50. Side H is 64. Okay. What do I do when I have all three sides? Yes, I have to do law of cosines. If I want angle G up here, this is the one across from it. So I start with that one. Okay, anybody besides Kayvon tell me how this goes? 64 squared. Okay. Cosine of whatever we're looking for, right? Okay, now what are the steps to solving though? What am I going to subtract from that guy? Okay. And you could add them together first and then subtract them, but that you got to do all that. And then all of this is still multiplied by G, so I'm going to end up dividing by all that. And that's still the cosine. All right. Anybody remember what it was? 50 squared minus okay. And then the divisor was -2 times 64 times 39, right? Okay. So I have two negative numbers. Well, yep. Don't know what that said. -3117 over -4992. Okay, and I have to do inverse cosine of that, right? Or second cosine of that. This is going to come out positive, so it's going to be an acute angle. If you had a negative and a positive in your parenthesis here, so that you were taking the inverse cosine of a negative, you would get an obtuse angle, okay? So if I go back here and I do second cosine of this number over this number, I get 51.4 degrees. There is not ever a second possibility when you're doing law of cosines, because the signs are different from quadrant 1 to quadrant 2, so the sign takes care of there being more than one possibility. If it's positive, it's going to be acute. If it's negative, it's going to be obtuse, and you're done. Okay? What if it's to find an area of this triangle? Let's warm up today. So this one says I have some triangle BCD with angle B being 16 degrees, side C 27, and side D 3. It's a funny looking triangle. Anybody know the area formula? This is not a law of sines or cosines question, guys. The area formulas are on your reference sheet. They're in two places on here. They're both in little boxes on the side with all the identities. Do you see them? If you know all three sides, you can use that goofy Heron's formula that's a pain in the neck. Okay? But For this particular triangle, we know two sides and an angle in between. So we can use that other area formula down there. And it says area is equal to 1/2 the length of the side times the other side times the sine of the included angle. And that's it. It's just a typing question. You just have to know where to find the formula and how to use it. So 0.5 or 1/2 times 3 times 27 times the sine of 16 is the area of 11.2 square units. On the quiz this time, there's labels on all of them, so if it was centimeters, you'd write centimeters squared. Any questions? Okay, if you are still clueless about law of sines and cosines, please come in and get some help because they're real important in the scheme of things. All right. Yep, totally don't know what I'm doing here. Going back to this one, maybe. Okay. Today's lesson. If you can't see, guys, someone could turn the front lights out, but we're about verifying trig identities today. To verify an identity is, in my opinion, easier than what we were doing yesterday almost, because I'm going to tell you what you have to end up with. You just have to figure out all the steps in between. It's a proof, okay? It is to prove both sides of an equation are equal. This is done by transforming the expression on. What does that say, guys? Can you read that out loud? Out loud?
One side.
One side only. Okay, you can only work with one side until it looks like the other side. One more time to clarify, you can only make changes to one side. If you change both sides on the quiz, it's going to be a concept error, okay? A verify question where I give you, okay, so this is what it says at the top. You must work with one side only, must show all steps so that I can clearly follow your work, okay? And by all steps, that means like if you're getting a common denominator, you got to show me what you're multiplying by, okay? If you're using a Pythagorean identity trade, just write like, as long as it's clear what you did, I'll be fine, but you could write Pythagorean identity there. All right, this question, you can work with the left or the right. This question, they chose to work with the left side. They traded the top for a Pythagorean identity, tangent squared. Then they made the top sine squared over cosine squared and the bottom 1 over cosine squared. And then to show you divide by multiplying by the reciprocal, they rewrote the bottom one flipped over as cosine, or cosine over 1. And then the cosine squared canceled, and you wound up with sine squared, which is what you have over here. Some teachers would have you write equals right-hand side to show that it's equal from up above. Or you could just show that you've gotten it to equal what it was. I'm not super picky about that. Any questions? All right, so let's try this one. Would you like to work with the left side or the right side? Okay. What do you want to do with secant minus cosine? Secant would be 1 over cosine minus cosine. Okay. What do you want to do now towards getting it to look like that? Common denominator, okay? If you're going to get a common denominator, you need to show me how you got the common denominator. So you need to show that you're multiplying this. If you want to use multiple colors or you just want to write it right in there, I don't care. I'll figure it out. So then this one becomes 1 minus, this is what? Cosine squared. And it's all over the common denominator of cosine. That is the least steps you can show me. Okay, you could have in here put 1 minus cosine squared and shown that this was over a cosine and this is now over a cosine, and therefore I can put them together as one fraction. Okay, you don't have to show that step, but you have to show that you multiplied by cosine over cosine. All right, now what do you want to do? Any ideas here? What could we trade a 1 minus cosine squared for? That's a Pythagorean identity. What is 1 minus cosine squared? So now I have sine squared over cosine. How am I going to make that sine tangent? Lillian? Doesn't seem like a good use of your time. Yeah, sine squared is sine times sine, right? And it's all over a cosine. But if I kind of just move that cosine so it went with this one, that's legal, right? So now I have a sine times what is sine over cosine? Is that what we were looking for? Okay. So I'm just showing that it's equal from up here. I don't care how you write that. I'm not going to be super picky. But you do have to show those steps. This is, I already know the answer, guys. You got to fill in the work, okay? And you got to make clear steps. Pretty good? What about this one? Which side maybe you want to work with here? Yeah, I would definitely work with the right. I don't know how to change secant until we've got all this garbage going on, but I'm hoping we can simplify all that garbage down so that we end up with a secant. All right, so what do you want to do here maybe? If I know you guys at all, you want to change these to sines and cosines? So tangent is sine over cosine, and cotangent is cosine over sine. If you don't have those memorized, this is 3 times more difficult, okay? But they are on the peach sheet. Now what do you want to do, though? You want to distribute that through? Okay. So times the first one, it will become a sine squared over cosine. What do you want to do with the second one here? Yeah, if you distribute it here, you would have sine times cosine over sine, and then those would go away. So you have a plain old cosine. But it has no denominator, so what are we going to have to do? Okay, probably need to do something to make this have a denominator of cosine. So it means we're going to have to multiply it by what? Now, I forgot my thetas some places, and I wouldn't count off for that on yours either. Now I end up with a sine squared plus a cosine squared. And each one is over cosine. If you want to just show it all as 1 over cosine, I can follow that work. Okay, this is about the minimum you would need to show. And then what? Okay, so this is a Pythagorean identity. And you don't have to label that. I'm going to assume you got that from the sheet and you know that. All right. And then 1 over cosine is the definition of. So we wound up with this side equaling this side. All right. This one's super easy. Can I just skip this one? Because what's sine, guys? Sine over cosine. Cosecant is 1 over sine times cosine. What happens? Cancel, cancel. 1 equals 1. That's the work, okay? That's the whole thing. That's all you got to do. Good luck. All right, this one looks a little miserable. Let's start on the left. That's a great plan. So you want to do sines and cosines? Can I do anything with the bottom? Like, it doesn't have any squares, right? Besides which, I don't think there's a Pythagorean identity with cotangent and tangent. So if I start on the top, I have a 1 over sine. What do I have on the bottom? Cosine over sine plus sine over cosine. Now there's several ways we could do this. We could just deal with the bottom and get a common denominator, or we could multiply through by the common denominator of the whole fraction. Any preference? What would a common denominator be for everything here? Sine times cosine. So if we multiply a sine times cosine onto the top and a sine times cosine onto the bottom, it will actually get rid of all of the fractions that are making a complex fraction. You'll be down to a single fraction. So what happens up top? 1 over sine times sine would just be 1, so you just have cosine. Yes, this cancels out and you just get cosine. Not 1 over, it's just cosine, right? Okay, now we got to distribute down here, so we got to be a little bit careful. What is sine cosine times cosine over sine going to do? Yes, the sines will cancel, and I'll have a cosine times a cosine, which is a cosine squared. Oops. I'm mixing my thetas and my x's, sorry. And then when I do this times this, sine over cosine times sine times cosine, the cosines will cancel because one's on top and one's on the bottom. I get sine squared. And the denominator is all 1, so I just have cosine over 1 or cosine. Definitely could have done that with more steps by getting the common denominator down here first. But this is a method you have to use in calculus a lot. Multiply the top and the bottom of a complex fraction by the common denominator. All right, there's a question like this on the quiz. Might want to put yourself a little note. Going to have to do what to be able, I'm thinking we should work with the left. What are you going to need to do to make this simpler? To get a common denominator, right? So I'm going to rewrite that step. Okay, what would I need to have as the common denominator, guys? Yes, sine y minus 1 times sine y plus 1. It's going to be my common denominator. So this one would need to multiply by sine y plus 1 over sine y plus 1. Could I scrunch that a little more? And this one would multiply by sine y minus 1 over sine y minus 1. You got to show that step. So now I have all this on the top. Sine y plus 1 times 1 is just sine y plus 1. But be super careful. What happens over here? Yes, this is being distributed. So you have a negative sine y, and a negative 1 times that negative 1 at the back is a plus 1. Then what? What happens to the top? Those subtract away, right? And then 1 plus 1 is 2. That seems good because we're supposed to have a 2 somewhere, right?
Yes.
Did I lose you, Tristan?
I think
We distributed the negative. Good. Okay. What else could we do right now with that denominator? It isn't part of this, so I'm thinking we need to do what with it? Well, change its form. What could we do to those two pieces? Yeah, FOIL them together. So what's sine y times sine y? Okay. And then we'd have a minus 1 sine y and a plus 1 sine y. You can show those if you want. You don't have to. I'm okay if you just skip that. Then a minus 1 times a plus 1 would be a minus 1. So those are going to make 0. Then what? Sine squared minus 1. What is a sine squared minus 1 equal to? Be careful. The identity says sine squared plus cosine squared equals 1. If I want it to be sine squared, subtract the 1 over to this side, what am I going to have to do with this guy? I got to move it to the other side, so it's negative cosine squared. Or you could just trade the sine squared for a 1 minus cosine squared, and then the 1 and the minus 1 back here would go away, whichever way makes sense to you. But we're going to end up with 2 over a negative cosine squared. I don't know why I changed to theta. It should be a y. I'm sorry. And then I have a negative and a 2. I'm going to just pull those out. And then what's left? This is 1 over cosine squared. And what is 1 over cosine? Okay. Is that what we started with on the right-hand side up above? Okay. The one on the quiz is very similar, except I think it doesn't have the negatives going on. It's not quite as crazy. Okay. But you have to get a common denominator and show your steps. And I think there's some on the homework that way as well. Any questions on that one? All right. What do you want to try here? There's some on the quiz where you are on the homework where you have to do factoring. I don't know that we want to try factoring this cubic. Well, and you don't really have to do factoring. You could just work with, you want to try right-hand side or you want to factor a cubic? Okay. So what are we going to have to do over here? We have to FOIL this mess together, right? 1 times sine would be sine. This is like an AB or a 2x or something. It's a sine cosine. Well, let's see. If we do FOIL in order, we did first times first, then we do outside. I never do it in the right order. So you'd have 1 times negative cosine, which would be a negative 1 cosine. Then you do inside term times inside term. What's sine times cosine times sine? Yes. Sine, it's positive, and it's sine squared times cosine. And then last times last is this ugly mess times this negative cosine. What would happen there? Sine times cosine would be sine cosine squared, and it had a minus. Okay. Do those just undo each other? No? This is a mess. Any ideas?
I'm the one like the one
but this is a sine squared cosine, and this is a sine cosine squared. Okay, the only thing I can think of to do is rewrite them in a different order. So I'm putting this one with this one. If we factor if you factor a sine and a cosine out, then you'll have sine minus cosine, which isn't anything either. I think if we rearrange, I hope this is going to work. There's not one like this on the quiz, I promise. Okay, so I'm doing the first, and I just put these two together, and now I'm going to put these two in order. A minus cosine x minus sine x cosine squared of x. Okay, here's my idea. Not such a good idea. All right, I'm changing this. I'm going to move this one up here, minus a sine x cosine squared of x. And then I'm going to put these two together. Sine squared of x, cosine of x, minus a cosine of x. Okay, what can I take out of these two, guys? If I take out a sine, what will I have left? 1 minus cosine squared. Because when you take a sine out of a sine, you still have 1. Remember, it's got to FOIL back in or distribute back in. Okay, what can I take out of these two back here? This term and this term? A cosine. This is like factoring by grouping, and it's really nasty. If I take a cosine out, I'll have a sine squared minus 1. Okay, what is 1 minus cosine squared, guys? 1 minus cosine squared is sine squared. What's sine squared minus 1? We just talked about that. Cosine squared plus sine squared equals 1. So if I want a sine squared minus 1, I got to subtract this guy back that way, so I get a negative cosine squared. So what does that come out to be? Sine times sine squared is, and a cosine times a negative cosine squared, which is this. Okay, I promise that's not on there. That's really gross. Icky, icky. All right. We should probably do either 7 or 8. You guys pick. 8? Okay. I'm thinking we want to work with the left, yes?
Yeah.
So we need a common denominator to go any further. What is the common denominator going to have in it? This one has to multiply by, what's the common denominator going to be?
1 plus cosine times.
So this one needs to multiply by a sine over sine. And this one over here needs to multiply by a 1 plus cosine over a 1 plus cosine. All right. So what do we get up here? Sine squared. But now we have to FOIL this together. 1 times 1 is a cosine times 1 would be a cosine. Plus 1 times cosine would be another cosine. Plus cosine times cosine would be cosine squared. Well, that's a hot mess. Any ideas? A sine squared plus a cosine squared is what? Can I do that? Why can I do that? They're all added together, right? So can I just move this up here and add in any order I want? Right? So then these two add together to become what? So now what do I have on top? 1 plus 1 plus cosine. 1 plus 1 plus cosine. And it's all over a 1 plus cosine times a sine. Distribute on the denominator. I think undistributing in the numerator would be a better plan. We're trying to get a 2 times a sine. 1 over sine, right? Cosecant would be 1 over sine. So we need to get a 2. How can we pull a 2 out here? And that will leave us on the top with 2 divided by 2 is 1 plus over 1 plus cosine times sine. What happens? You can cancel this because it's an entire quantity, right? It's not being added or subtracted to another quantity. So then I have left a 2 on the top and a sine in the denominator, which I could write like that, which is 2 cosecant. Yep, that's not on the quiz either. I'm not going to spend time on this because I checked your homework and it's not on there. The bookwork has some questions that I didn't assign apparently, but where you plug these in, like you put in y1 the left-hand side, and how do you get a cotangent, guys? You could type cosine over sine, or you could type 1 over tangent, right? Because your calculator has those things. So I typed sine of x plus cosine of x times 1 over tangent of x. And then in y2, to get this side, I did 1 over sine of x. And then the question is, are they exactly the same graph or not? Okay. If they are, then it's an identity. If they're not, if they have any places where they're not overlapping, then it's not an identity. But I didn't assign any like that. So there are 3, 4, 5, 6, 7 questions. Some of them you're going to have to do some factoring. For example, anybody know how this would factor, this number 17? Guys? If you have an x to the 4th minus y to the 4th, how does that factor? X squared minus y squared times x squared plus y squared. And this one factors again if you need it to, right? Okay, that will be useful here, cosecant squared plus cotangent squared, because what is that? Anybody know what cosecant squared minus cotangent squared is? I think it's just 1. And then you have to get rid of the cosecant because it only wants cotangent. If you trade that for a 1 plus cotangent squared plus another cotangent squared. All right. Do the homework. I'm here tonight if you need help.